Okay, so at this point in the lab, I have already rolled the marble. Again, I'm only rolling the marble one time, and the photo gates are going to collect all of the information that I need. So I'm going to start off by filling out my chart. If we are following the directions in order, it says that we are to roll the marble with our CPO timer box in interval mode. And remember to reset your timer box before you roll the marble. You always want to reset before you collect your data. And so the instructions say that we are going to toggle these lights here to get the data that we want. So if I'm following the handout in order, it says I'm going to first turn on the light for photo gate A. So when the light is on only for photo gate A, this number represents the amount of time that it took for the marble to roll through the first photo gate A. So I am simply going to record this information onto my data table right here for photo gate A. So the time is 0.0132. Okay, then it says, I'm going to turn that off, and I'm going to turn on the light only for photo gate B. So this tells me how much time it took for the marble to roll through the second photo gate on my ramp. Notice that this is less time. It should be moving faster as it goes down the ramp. So the farther down the ramp, the faster it is. So it would make sense that the time here is less. Okay, so that's kind of one way that you can double check to make sure that you have your photo gates plugged in and connected correctly. But this is less time, so now it takes only 0.0095 seconds for the marble to pass through photo gate B. Now it says that we are going to turn on both lights, and so this is a unique feature for this timer box, which I think is really pretty cool and convenient. We are also able to collect time as if this were a race, where my marble in this case is not starting from 0. You are going to put the marble on the ramp at the 0 meter mark. But remember, by the time the marble reached the first photo gate, it was already moving. So when it hit the first photo gate, we start collecting data. When it hits the last photo gate, we stopped collecting data. So this right here gives me the amount of time that it took for the marble to roll. I almost said run. The marble is rolling from photo gate A to photo gate B. And so that is this place on the data table. So 0.1885 seconds. So almost 2 full seconds for my marble to go from the first photo gate to the second photo gate. Again, if we were following the handout in order, step number 3 is asking me to fill in my distances. It is telling us to use a distance of 1.9 centimeters, which you should have converted to 0.19 meters. Again, as I explained before, the diameter of the marble is the distance, because this is basically triggering our timer by blocking the sensor. So we are going to put the distance through photo gate A as being 0.019 meters. That's how far the marble rolled during the 0.0132 seconds. For the second photo gate, it's the same marble, so it's going to be the same distance. The marble rolled one time, so it rolled a distance of 0.019 meters, and it took 0.0095 seconds to go that distance. Again, it's moving faster at this point. Then we are being asked to fill in the distance for A to B. It doesn't say that specifically, but we are going to fill in that information. So let's go ahead and do that now, since we're on distance. Again, this is taking us from the first photo gate, which was at the 30 centimeter mark, to the second photo gate, which was at the 60 meter mark. They are 30 centimeters away from each other. So our distance here is 0.30 meters. We are actually not going to need or use this value in our math work, but I just like to make sure that we comprehend our setup and we understand where that value comes from. So that is going to be 0.30 meters. Now the assignment is asking us to calculate our speed. So over here in step 3, we were going to figure out what that distance was so that we could calculate the speed. And remember, speed is distance divided by time. Distance divided by time. So in order for me to find out how fast the marble was rolling through photo gate A, I am going to take the distance traveled of 0.013 meters. I'm going to take the time of 0.0132 seconds, and I'm going to calculate my speed. So if I'm plugging this into my formula, it looks like that, distance divided by time, and that value comes out to be 1.4393 ... right? There's more digits in my calculator. So that is how fast the marble is rolling through the first photo gate. By the time the marble got to photo gate B, it is now moving faster. So we have to calculate what is that new speed. Again, my formula is the same. My speed is going to be the distance traveled of 1.09 meters, that diameter, divided by the time that it took the marble to pass through the second photo gate. So now that comes out to be a speed, in this case, of exactly 2. I'm going to jot down a couple of decimals there because we did have several significant digits here in our timer. So we are going to have 2.00 meters per second. Now, if I'm being specific, look here. Our displacement was, or our distance, was given to us in only 2 sig figs. So when we get to our calculations or our graph at the back, we'll switch that and narrow that down to 2 sig figs. Okay, so now we are being asked to calculate the acceleration. The handout here has a place for you to first find what that change in velocity is. Remember, acceleration is going to be the rate of change in velocity. So my acceleration will be final velocity minus initial velocity. Okay, divided by the time. And again, this scenario is what rate did it accelerate when it went from this speed to that speed? Well, remember, this value tells us how much time it took for it to change speeds. So we are going to put 0.1885 in my denominator. This is how we calculate acceleration. The handout simply gave you a place to calculate that numerator for those of you who like to do it in steps. And then we're going to take that simplified value, which for me would be 0.56 meters per second. So the difference between my two speeds here was 0.56 meters per second. That would be my numerator. That's my delta V, change in velocity, divided by time in order to get my acceleration. So my acceleration rate here is 2.974. And if I'm keeping that in my calculator, I actually know more digits, but there's a few of them just so that we can talk about what we need to know. So this is how you complete the front data table. Now, as we turn the paper over, I already put some values on my graph. You guys are going to need to be able to scale your own graphs in the future, so we can have a conversation if needed about how to decide that scale. But what I want to point out to you here, even though I did not write it, my origin here along the x-axis, this would be a value of 0 seconds, and then we begin counting 0.02 seconds, 0.04 seconds, 0.06 seconds. So I'm not reaching a tenth of a second until I get all the way over here to 1.0. Okay, and that's just because my times were so small. For the y-axis, again, I have to start at 0 meters per second, but then I am going to count so that each of these lines have equal values. It's very important that you scale them so that each grid represents the same value. Now you guys are going to need to come in here and you're going to need to write that this represents my time in seconds and this represents my velocity in meters per second. Make sure you do that so you can earn full credit. You can see that I have already filled in some of the numbers here. So I took the 1.4393 from the data table in the front, and I simply said, when my two photo gates, so remember, here's my setup, photo gate A, photo gate B, when my marble hit this photo gate, it was already moving at a speed of 1.4 meters per second. That's why 0 seconds has a speed of 1.4 meters per second. So on my graph, I am going to find 0 seconds of time. Again, you will write in your label here for time. We have a velocity of 1.4. So my first data point belongs here for this graph. Then the next speed we've already decided is 2 seconds. When we got to photo gate B, it came out to a perfect 2 meters per second. So I have already written that down, but I did not fill in the time. So if you recall, we said the amount of time that it took for the marble to go from photo gate A to photo gate B, okay, that was the 1.885 seconds, almost 2 seconds of time, right? So I need to take that value and put it here. That's how much time. I didn't sig fig that because that's just data that I collected. There were no calculations, no limiting factors. This is how much information I was given, so I copied the whole thing. So now, when I come to graph this, my data point for the velocity through photo gate B will be a value of 2 meters per second. So again, you will write in, this is velocity in meters per second. Here's my value of 2 meters per second, but this is 1.8 seconds later. So I have to come across my x-axis and find where 1.8 is located, okay? I'm sorry, not 1.8, 0.18. Sorry about that. So my graph shows that 0.18 seconds is here. My speed is up to 2.0, and so this is where I'm going to write my data point. Okay, so these are my 2 points on my graph. Now I am simply going to get some sort of straight edge. You can use your ID, you can use the edge of a calculator, you can borrow a ruler, and we are going to draw a line. Remember, we do line graphs in this class, so we want to take our straight edge and we want to simply put it through these 2 data points, and then we're just going to draw a line. And this shows the trend of my marble as it rolls down the ramp. And that is how you complete your data table, and then you will fill in the answers to the subsequent questions below.